Okay, today we're going to learn about something called a sex-linked trait. And sex-linked traits are traits that are linked to the sex chromosomes. The one we're going to, or the type of traits we're going to learn about are traits that are linked to the X chromosome. And I'll give you some examples in a minute, but let's just review that humans have 23 pairs of chromosomes. And on the 23rd pair, that's the last pair, that's the pair that determines the gender. So if you remember, males have XY and females have XX. So we're going to talk about an example of one of these traits, and that example is colorblindness, being colorblind. I linked a video to the Google Classroom that you can watch on what it's like to be colorblind, because a lot of us think we know, but we really have no idea. So watch the video; it's pretty interesting, and it'll give you a view into somebody who's colorblind. You can see what they see and how they see things. So in order to be colorblind or to carry these X-linked traits, you have to have a marker or like a gene present on the X chromosome, on every single X chromosome you have. So let's start by looking at males. So males, a normal male, so a normal vision male, is going to have XY as his sex chromosomes. A colorblind male will have a genotype of X with this little C attached, Y. Sometimes a C will be used for other traits. They might use an H or an R or whatever it may be, but you'll be given that information just like when you learn, or when we did like tall and you use T, or brown eyes and you use B. So a normal vision male, XY. Colorblind male, X with this little C like an exponent in math and a Y. Now, so males can either be normal vision or colorblind. Let's look at females because this becomes a little bit different. A normal female, as you remember, has XX. A colorblind female has X with the exponent C, and the other X has the exponent C. If you remember, I said in order to be colorblind, something has to, or this gene has to be present on every X chromosome you have. So because females have two X chromosomes, they must have this little C or this marker or this gene on both, oops, I already said X, on both of their X chromosomes. Now, the female could also have this combination where there's only a marker or a gene on the one X and the other X is totally unaffected. This female is going to have normal vision. So she's going to see normally. She will not have color blindness, but we call her a carrier. And all that means is that she can pass this gene on to her offspring. So it's very similar to when we talked about brown being dominant for B, if we're talking about eye color, and lowercase b would be for blue eyes. Let's say that the mom had this genotype. She's going to show brown eyes because brown is the dominant trait, but she could pass the blue-eyed gene onto her offspring. So it's the same thing with color blindness. She's going to have normal vision because it's recessive being colorblind. You need something on both. But she could pass this gene on to her offspring. So that's all that means. How do we show this in a Punnett square? So let's just say, and you have all these examples in the Google Doc that I shared with you, but let's say we have a colorblind man. So we're going to set up a Punnett square. The man is colorblind, so his genotype would be X with the C attached and a Y, and let's say the mom is a carrier. So I'm just setting this up like I would any other Punnett square. Now I'm going to fill in the pieces. So when you fill in the Punnett square, the letter attached to the X, that little C, that exponent, just moves with it. Like think about it as if it's Velcroed there. It can't move off. And then you'll have your normal questions like you've had. So what is the chance that an offspring could be colorblind? And if we look at the box, and we'll evaluate them all now and see, I look here, this one is colorblind because both X's have it. This male only has one X, but it has the colorblind, so that's colorblind. She is a carrier. She will not be colorblind. She could pass it on to her offspring, but she's not, and this is a normal male. So when we put our percentages, we don't include the carrier in the percentage. So this is 50% because 2 out of 4 boxes are showing the trait. Let's just try one more. So we'll make a Punnett square. This time I'm going to talk about fruit flies. Fruit flies have red eyes or white eyes. And it's a recessive trait. And you'll see this in the notes that I shared with you, and you'll see some pictures of it. So if they have red eyes, the X is just going to present normal. If they have white eyes, there's this letter attached to the X. So in this case, we're going to use a normal male and a white-eyed female fruit fly. And I'm going to fill in just as I would any Punnett square with the little letter attached to the X. And then my question is, what percentage will have white eyes? And so when we evaluate this and we look at it, this one is a carrier because this X doesn't have anything there, so that's not going to have white eyes. This has both X, oh, I'm sorry, one X, and that X has the gene on it, white eyes, white eyes, white eyes. So, oops, I made a mistake. Let's go back. So I made a mistake here, and we'll just fix it. Oh. So if we go back, I carried an R down, and there was actually no R there. So this is a carrier, normal. This one here is colorblind, and this one is colorblind. So 2 out of 4 boxes is 50%. Check out the notes. There's some practice questions there, and then work on the worksheet that's been attached. Have a great day.